charge, am I right? Just double check and correct me because I don't remember this our formula everything. dV in cylindrical system is rho d z. Then there's gonna be triple integral rho c and z. What is the rho? Is gonna be 6 rho 2z. 6 rho 2z. Then we have another rho here. Is gonna be rho 3. Or let me say 6 rho z with another color, put 3, which is different from there because of this rho. Then d rho d z. Rho is from 0 to 4. 0 to 4. 0 to 3. And phi is from 30 degree to 90 degree. It is pi over 6 to pi over 2. First problem is super easy, am I right? We need to solve this integral. So, do you see any phi here? Then the differential value between these two gonna be the result of that. For this part is gonna be pi over 2 minus pi over 6. Make the denominator similar, multiplied by 3 here. 3, 6. Then the result is 2 pi over 6, which is pi over 3. Now I can remove this integral. I can remove this and put pi over 3. I will solve it for z first. For z, this part is gonna be constant, and z gonna be z2 over 2. Then it's gonna be 6 rho 3 z2 over 2, 4. This one is gonna be 3. The result for 0 is going to be 0, instead of 3 is going to be 9. 9 by 2, and this is going to be 9 by 3 is going to be 27 rho 3. Now we solve for this one. The result is pi over 3 by 27. I can take it out. The integral of rho from 0 to 4 rho 3 d rho, which this is going to be cancelled with this one partly. It's going to be 9 pi rho 4 over 4. Just put 4 there, find the value. A surface charge with density of rho s 5 rho z exists in the surface defined. There, calculate the total. Another cylindrical system. This one, this time, is a surface. cylindrical system, it is at the surface of a cylinder. Then the ds is gonna be phi is changing and z is changing. Because phi is changing, we say d phi dz. It is at the surface. The rho is constant and the value is 4. I put the value here. I want to find the charge. I don't care about the direction of this. And because of that, I don't say it's going to be a rho. Now, it's going to be surface integral 5 rho z from 0 to 8, 5 rho z, and phi is 4500. Phi from pi over 4 is very easier in this way. 2 pi over 2. And they're going to be 4, it's going to be 20. D phi dz. The rho also, we said that how much is that? 4. Then it's going to be 8. The result is double integral of 80, 0 to 8, at infinity. Pi over 4, 2 pi over 3. Only z is a variable, d phi is. For phi, again, is going to be the differential value between these two, because there is no phi here. It's going to be 2 pi. It's going to be 2 pi over 3. I can say it like that. The result for that one is going to be pi over 4. It's going to be 2 pi over 3 minus 4 pi over 4. The denominators are not same. To make it same, I multiply this one with 4, this one with 3. It's going to be 3 over 12. 4. It's going to be 12. Then the result is 5 pi over 2. The result is 8. 8 multiplied with 5 is going to be 40. Am I right? It's going to be 400 pi over 12. The integral of 0 to 8 of z dz. This is going to be, of course, can be simplified. It's going to be 400 pi over 12. Z2 over 2 from 0. Final. Point charge of 2 nano coulomb, 6 nano, and minus 16 nano are located at this location respectively. Determine the force on an 8 nano charge located at origin. Is it difficult? How much? 8 nano at origin. So I don't want to find the exact location. This gonna be like this. Maybe the location of this point. One of them is, let's say, 2, 6, minus 6. Minus 16, 6 nano, and 2 nano. Okay, we have a condition like this. Because it is origin, it is easy to find this vector between them, the line between them, this R. We call it R1, R2, and R3. Correct? So, what was the formula? The force or electric field was sigma of, go ahead.
Q2, Q, or Q squared.
This Q is a common part for all of them. I can say that 8 nanocoulomb sigma of Q I, this is Q1, this is Q2, this is Q3. Am I right? I said QI, I from 1 to 3, over 4 pi epsilon 0 R I Q A R I. Am I right? This is the formula. What is R1? We need to define. Because we have Q1, Q2, Q3. R1 is this point minus this point. This is 0. 5, 0, minus 2. This is 5AX minus 2AZ. R2 equals 1, 2, 3. AX plus 2AY plus 3AZ. R3 equals minus 4 and 6. Minus 4AX plus 6AZ. It doesn't have AY. So now, what should I do? Put it there. The magnitude of this also is easy. 5 to the power of 2 plus minus 2 to the power of, I don't need to put minus, just put it. The magnitude is going to be 1 to the power of 2 plus 2 to the power of 2 plus 2. And this one is minus 4 to the power of 2, which can be positive eventually, 6 to the power. Now I can say that 8 nanocoulomb multiplied with Q1 was 2 nanocoulomb. AR is 5AX minus 2AZ over 4 pi epsilon. I can take it out. 4 pi epsilon is the same. And here I put 25 plus 4 is going to be 29. And then is going to be the second one, 6 nanocoulomb and AX plus A2 A1 3AZ over 5 and 9 is going to be 14. Plus minus 16 nanocoulomb minus 4 AX plus 6 AZ is gonna be 36 and 14 is gonna be 50. Close the bracket. You see, this is a vector and vector and vector. You can simplify that. Eventually, it's going to be one vector, which is the force applied to that charge.
52. 16 plus
16,
36.
okay, yes.
So isn't it like the point that you're like where the 8 nanocoulomb, the 000 minus 5050 magnitude? So it should be like R1 should be multiplied by
This one to this.
Minus,
Am I right?
yeah.
You subtract this point from origin.
From origin?
Yes.
okay.
Target from the origin, the location. If it is opposite, only one negative you put there. If I made a mistake, I can correct it with one negative. But just check that. I think it was something like this. But the result gonna be yes.
I'm supposed to get like resultant force direction, like a final direction. This is like.
It's gonna be a vector eventually, has three portions, AX, AY, and AZ. If you simplify that, all of AX gonna be added together, all of AY added together, and all of AZ added together. It's gonna be single vector.
It's not gonna be like a one direction.
The vector, direction of the vector, which we define it in X, V, Z direction. It's gonna be one vector, probably something like this maybe, the force. I don't know. But direction of that force, check the definition. If I put the location of charge minus the original one, then it's gonna be one negative, just the difference. Just double check that.
Are the solutions also going to be posted in Canvas so that we can come back?
I did already.
Okay, so the solutions are already posted.
Yes, solution is there, but a little bit different from this, the numbers, but the approach and everything is there. Determine the force on find the electric field at the origin. So, how to find the electric field?
Divided by
Divide this one with 8 nanocoulombs, because at that location needed. You find the force at that location, divide everything with 8 nano, then it's gonna be electric. Super easy. The gearing is a part B. A circular disc of radius A located at Z, Z0. Something like this. I don't need to put this one something. Radius of A, here is A. It's uniformly charged with rho S. Find the electric field at this location.
Bless you.
It is at H. How to solve it? We can solve it with the surface, but if we had a ring, electric field, it was easier, one integral. Now, we have to define sample here, calculate the electric field. We know it about the symmetry. This one generates electric field. It has two portions, one here and one here. This one gonna be cancelled with the other one here from another sample from here. Then we know that the result, the electric field has a Z direction only. So we sweep this surface and we are done. So ds in cylindrical system here is phi changes and rho changes. It's going to be rho d phi d rho. Okay. Then we need to find this R. For finding this R, we have this location which is H, A, Z, and this rotation is what? You remember? This was, it is DS actually. This location, it was this one was rho, location it is rho, d rho plus rho d phi. Am I right? No? How did you solve it? You did that way? So, okay. I made a mistake. It's gonna be rho, not rho, it's gonna be rho A rho. Sorry, I said D rho. Okay? This is gonna be the location plus the location is gonna be like this, or
And then the big R is gonna be R1, it's gonna be like HAC minus rho.
okay, the location regarding A phi gonna be 0 because it's gonna be symmetrical. That's why I'm confused. Okay? Now it is correct. Then R gonna be based on the definition, it was from the location minus this. If the direction is something like this usually, then it means this one to this. Then the previous problem was correct. Am I right? Or we subtract.
For the previous problem, I think you did it backwards, you subtracted.
This is R1. Yes, you're right. This is R2. Let's write it. Then it's gonna be R2 minus R1. Just minus. In previous problem, you add 1 minus. My calculation is correct. Then it's gonna be R2 H A Z minus rho A rho. results for a point charge over rho s ds 4 pi epsilon 0 r to a r. Okay, that's what we need to solve. Now in an integral form, there's gonna be two integrals from 0 to 2 pi because of symmetry. We know what's gonna happen, but we repeat it here from 0 to a, and rho s ds is rho d phi over 4 pi epsilon 0 So in this case, I can say that rho s ds also 4 pi epsilon 0 r 3 r. A r equals r over magnitude of r. This is easier. Then it's gonna be h 2 plus h2 plus where is that rho 2? Rho 2 to the power of 3 because of this 3, but absolute value is gonna be 1 over 2. It's gonna be something like this. And the direction, we know that there is no direction of a rho because they cancel each other. It's gonna be az only. The az of r gonna remain when you calculate that. So if I put h a z minus rho a phi, I know that this is gonna be 0. Then my integral for this part, because there is no phi here, is gonna be 2 pi minus 0, which is gonna be 2 pi. Rho is constant. This h is constant. I take out everything. It's gonna be 2 pi rho s h over 4 pi epsilon 0. The only integral is 0 to a. It's gonna be d phi. We saw it. It's gonna be rho d phi over. Of course, I can take az out as well. The rest is h2 plus rho 2 3 over 2. So if I consider this is u, then u is gonna be h2 plus rho 2 du gonna be 2 rho d rho, which exists here. I multiply with 2 and 2, then this is there. Then my integral is gonna be the integral of du. Instead of this, I put du over u to the power of 3 over 2, which is gonna be integral of u minus 3 over 2 du. The result, I need to add 1, is gonna be minus 2u to the power of 1 over 2. Now this is a solution. I return it back, it's gonna be minus 2 h2 plus rho 2 to the power of minus 1 over 2 from 0 to a. This is a solution. All right? It's not very difficult. Now, I put the value and see what's gonna be the result. I put everything here. It's gonna be minus 2. Instead of minus 1/2, the power. I can put it down here and show it in this way, maybe better sense. H2 plus rho 2, and rho from 0 to A. Am I right? Did I miss anything? No. Now, minus 2. I put A instead of here, it's going to be 1/H2 plus A2. Minus, I put rho 0 is going to be 1/H2. This is the result. Electric field at this point. Now in part B, it is saying that find E at 0, H0. What's gonna be?
Are you, what, meant to multiply it by the epsilon, the 1/epsilon, sorry, the 2 pi?
Oh, I missed all of this, yes.
Yeah.
I will call it a star and say equals minus 2 a star.
Okay.
Yes, thank you. I take it out of the integral, I forgot to return it back. Everywhere, here even that star is here, that star is here, this star is here, here. Everywhere that star is. Now, yeah, also everywhere, the star has AZ itself. The star has it. I don't repeat it. Okay. Well,
So I watched a lot of YouTube videos, kind of relating to finding the charge related to a disk, and they all just felt you used the ring method of like using the ring and integrating it that way. I use that method to solve this problem.
use my method.
Use your method. Okay.
Cannot find someone better than me in this universe. I'm not kidding.
Can't we use the ring method?
Yes, yes, you can use it, but here I didn't give you the electric field of the ring itself. Next problem is that one. Next problem, we find this one with the ring. But right now, I didn't mention any ring. Original way, surface integral. So, from here, it said, if you calculate link, when H goes to 0, what's gonna happen? Did you solve in the same way?
No, when you expand the star out, your H gets multiplied, and also the -2 just gets distributed into the bracket, and so it turns into rho s over 2 epsilon, and then in parentheses, 1 minus H over the square root of a squared.
So you see that in this star there is the H, am I right?
Yes.
Yes.
I'm taking that H out and put it here. Correct? Then this part is what?
Or
One.
Yeah, 1 over H squared.
So there's gonna be one H here, you don't care.
Yeah.
So eventually when we have here the electric field here, it must be 0, am I right? When you put H again equals to 0, this must return to 0. Is it correct or not? If it doesn't go to 0, it means that we made some mistake.
For at 0, 0, 0,
For H0, it said that
the whole thing is
the electric field should be 0. Am I right?
origin.
But you have the one, and so it's gonna be zero
It's
minus
gonna be-
one, which is gonna be negative one, and so the negative 2 star is gonna get multiplied by negative one.
Then I made a mistake.
Well, at infinity, it's gonna come to zero.
At infinity, definitely is gonna be zero when we put the h 0. But the result is gonna be like this. If this is 0, this is A, this is radius. Okay? No, it is Z. At Z0 it's gonna be 0 because at this point everything is symmetrical. Okay? Then it goes up high at some point, at some h 0 is gonna be a maximum and eventually goes to zero at infinity. So
But when you solve it mathematically,
because I didn't properly find the final value, I might miss something.
well, when we solved it in class,
We solved it in class and it was correct.
when we solved it in class, it was the same answer as this.
Is it because we don't have row S that it, like, we can't?
We
see
don't
this?
have what?
It doesn't give us an equation for rho S, the surface charge, so it's just a constant there, and, like, it would be an equation. So it would, like, it being 0 there would make that rho S equal to 0, that makes it the final bang 0.
Because-
I'm not sure about that.
For the problem, no?
So we are sure, this is from top level, we understand at this point must be 0,
Yes,
at infinity must be 0.
Yeah.
This is the way that we validate our calculation. So, because I ignore a lot of things here, maybe I made a mistake. Are you sure this gonna be like this? Minus 3 over 2 plus 1 is gonna be like that. Then 1 over 2 u 2h from 0 to a. The final value is gonna be minus, even minus we can change this, is gonna be 4, this gonna be gone, it's gonna be rho s over epsilon 0, it's gonna be all cancelled. Then it's gonna be 1 minus h over h2 plus a2. This is correct, am I right?
That is correct. It's 2 on the denominator of the constant outside of the parentheses.
Oh, it is 2, yes.
Yes, there were 2
Extra
extra.
2 because of that. And a z.
But then you also have to take into account the -2 that's multiplied by 1 minus h over the square root of h squared plus a squared. So the 2 cancel out.
No,
No, there's extra 2 here.
There's
Oh,
a,
okay.
I have the working out what we did in class.
So this is what we find today. In this case, when h going to the infinity, this gonna become 1, which is correct.
Yeah.
Okay? This part is correct. But when I put 0 for h, it goes to 0. It's gonna be this value.
That's right.
Yes, for 2 epsilon.
Is
it
it-
doesn't make sense to me.
When I put 0 for H, are we going to 0, 0, or are we going to when H, like, starts going from positive to negative, like when it changes? Are we going to the maximum value of the turning point? Because when you're working with integrals and derivatives, you get the maximum value by seeing when the slope changes.
Yeah,
to negative.
maximum values, you calculate the derivative of this, and put it equals to 0, then you find this maximum. But based on this extreme condition of 0 and infinity, it says that it's not something like this. But it can't be. Maybe it's because of,
That's what I was
Setting
saying,
up
that
the
the
equation where-
surface charge density is an equation that would be based on in what position it would be on the, like, on the disk. So,
Oh, yeah, the row has.
like, it would be, at, like, rho s would be 0 when height is 0. That's what I was.
no, imagine you have a disk. In the center of the disk, what is the electric field?
It
Because
should-
0, because from everywhere is gonna be symmetrical. Yes.
So you're
Even
in the
vertically?
disk, you're in the disk. Because if you're slightly above it at all, then there is.
Yes, there is. If
Right.
you are slightly above that,
Okay.
there is something. But in this case,
So if you're like in the disk, that's when it's all symmetrical, everything cancels out.
Is that because there's no vertical component of the electric field?
That's right, because you're in.
So how in the world did?
Maybe it's
This
just
is
so
that
small.
apparently I missed something here.
Did you say that?
It should be probably. Did you calculate it the same way, all of you?
Yeah.
A lot of us got PS over 2 epsilon, I would say.
Yes.
Rho s.
Row P, it's not P.
Where's that?
I have to working out when we did it in class.
It's
What?
I have to
What
work
about
out
this
when
one?
we did it in class, and we get the same answer.
We got the same answer.
All before.
So this is the value. But it doesn't make sense for me. I will find the solution. I mean the answer. I mean, you do what I did. Instead of h, you put 0, whatever the value you report. You consider h going to infinity, then this gonna be 1, the result gonna be 0. You just report whatever you calculate. The approach is important. But for 0, doesn't have meaning for me, the solution. Unless there is something regarding the thickness of this surface or related. But I will figure it out. The approach is important. The approach is completely correct. Okay. The last one, we have 15 minutes to finish this one because this one is very important.
It's gonna oversimplify. It's can happen. That's for any value.
Explanation on why it wasn't.
Yes.
Is it to run something to do
I'm thinking
and
that's
you hit it with
we
a
promise.
twice?
Because when you do the method, it's
Probably we made a mistake. I don't know where, but I will check.
when you do the method, it includes the cosine of the angle.
Okay. Now, everybody here, it's a super important question. We have this ring this time, not a this. This is the rho L. This is the this. This is the ring.
With the ring, it's not gonna be.
It's empty.
What?
With the ring at 0, it wasn't. Yeah, it wasn't 0. No, we're at infinity. I'm trying to figure out what was.
Okay. The radius again is A. At the height of the edge, the electric field is given.
I forgot.
Rho L A H A 0 over 6 pi Okay? Now we want to calculate the disk electric field using the ring electric field. So, assumption is that this disk made of multiple rings. So our integral is going to be over the ring, over the row from 0 to A. So, in this case, we have rho L in this formula. We have to convert it to rho S d R or rho, doesn't matter. Make sense? This is the important thing. Because here we define rho S for the disk. Now, this rho S, if we multiply it with dr, a little bit here, and multiply it with rho L, dr multiply it with ds, becomes rho L, okay? So imagine this is a surface, this is a line, the density of this one is rho S, okay? If I select little bit of this rho S, and this is R, dr part of that, then this dr with rho S equals the line density. This is what you need to understand to solve this type of problem. Nothing else you need.
Can you please explain that again? Sorry.
So, this is a surface, okay? This is a surface. These are dr. The density of this surface is rho S, okay? If I multiply this rho S or select a dr portion of that, dr is differential very tiny, then it became rho S dr, am I right? This is a rho S everywhere by dr. What is this one? Rho L itself. Rho L equals rho S by dr. This is the way that we want to calculate the integral. This is not, this problem is a circular everything, but this surface is showing that. This is rho S, little bit of that, that's the definition for rho L. Now, here we have rho L. We want to convert this one to the integral form, am I right? So here, instead of this rho L, we put this. It's a dr there, then it's going to be integral. Integral from what? R from 0 to A. Then, this is the ring. This is a disk. This is going to be integral of ring dr from 0 to A. Correct? Now I'm going to solve zero to A. Instead of rho L, I put rho S and dr. These two together is that rho S dr there. For the rest, same color. A, H, A, Z is going to be A, Z. Or I will put it outside, A, Z. 6 epsilon 0, H, 2, plus, it is dr. What is the R here in this formula? So r equals a. In this integral form, I have to change it to r.
Including the one on, in the numerator, the a in the numerator.
Is there anything? Yes, this one I have to change it. Thank you. So these two changes must happen to this. Then you have an integral. Again, this integral solution is similar to these u things. And the result is going to be the same because you consider this one u, then this gonna be du. Or let's say du gonna be 2r dr. You add 2 here and 2 here. Again, you take everything you don't need. It's gonna be rho s h a z over 12 epsilon 0. The integral of du over u 0. So the result is going to be the same. Only this part is going to be a little bit different. I mean, the factors. We have the solution. Well, still that same problem is there. But in this one, if h going to the infinity, the result is going to be 0. It is saying if a, the surface, go to the infinity, what's going to happen? It should be independent regarding the h because it's going to be infinite surface. With infinite surface, when you get away from that, electric field doesn't reduce. So I don't remember the results, but in that case, you put a goes to the infinity. Eventually, you will see that there is no dependency to h to the in the result. Very easy. Always fact checked. That fact check is more powerful. That's why in the other problem, still I don't believe, I think that we made a mistake somewhere. In calculation, the approach correct. So I need to redo the calculation and see where in the calculation I made a mistake. But the approach was correct. It should make sense with the higher level validation that we have. Now, another problem I want to solve. I'm going to solve this one. Imagine this is this not this, a ring, again, similar to this. And at H, I have the ring. Now I'm gonna calculate a cylinder. Surface cylinders, electric field, which the height here is up to, this is A, this is B, up to B. Again, with the ring result. The surface is something different right now. Rho S is there again, okay? Still, rho L equals rho S. This time the element is what? Consider one element here. Differential d what? Is z. I call it z prime, and I call it d z prime because it's easier for me. Later you will figure it out. It's going to be d z prime. This is the first thing to remember, and the conversion. So the distance from here, we call it z or h. But now, in this case, z prime, for the ring going up and up, what should I do? The h in this formula must be converted to h minus z prime. because every time it's getting from 0 to b, up to b. Now my integral of cylinder equals to, it's gonna be z from 0 to b, and instead of rho L, I put rho S, and A gonna be A because not changed, but H, I put H minus Z prime. dz is coming from here, rho S dz prime. Again, the direction is AZ. It is 6 epsilon 0 H minus Z prime to the power of 2 plus A to the power of 2, 3 over 2. Again, you see that if you consider this is U, somehow the du exists here, you can find it. Solvable integral. Okay? If you have an electric field of a disk, like what we calculated, something like that. And again, you want to make a volume disk, volume cylinder. Electric field, you can do this. Is it clear? Is it something challenging? This is super important. This part is very important. This part is very important. Then this integral is over z, 0 to b, from here to here. That's what you did. This is du, gonna be in this case, I wanna prove that it exists there. It's gonna be minus 2 H minus Z prime dz, okay? You again put a 2 here, multiplied with 2, then also you need to put a negative sign. You put one negative here, one negative outside to make this negative. Then this part, eliminating and you're putting A and rho S outside, this part gonna be du. So it's gonna be minus rho S A over 12 epsilon 0, also AZ, integral 0 to B du u to the power of 3 over 2. Again, you solve this one, but I usually don't put 0b because this is right now it is for u. If you want to put the right value here, because this is u equals to that value, instead of z you should put 0, and if you put 0 it's gonna be h2 plus a2 based on u, and h2 minus b2, no, h minus b to the power of 2 plus a2. Doesn't matter. It's better that you solve it for u, convert it to the original z parameter, and then put the value of 0 and b. Doesn't matter. This is also another way of doing it. So, another problem, we have 1 minute, 2 minutes. Imagine we have this disk this time, A, and the E of this equals to rho S A H, this is at H, A Z over just very simple, epsilon 0 H2 plus A 3 over 2. Imagine it is for the disk. I simplified that, just imagine. Now I want to see that the cylinder, volume cylinder, electric field, that the height is B, radius is going to be the same. What's going to be the electric field at there? The electric field of cylinder equals the integral for z from 0 to b of this electric field Bz. But the changes we need to make is that rho v equals slice of this. Rho v is gonna be rho s, already it is rho s, and this is gonna be rho v. Rho v is rho s dz. Okay? No. Rho s, the rho v slice of rho v gonna be rho s. And always we need to find the distance of each slice to this. This is gonna be h minus z prime. Let's call it z prime everywhere. Then h gonna be converted to h minus z. So in this formula, everywhere you have h converted. Eventually, electric field of cylinder is gonna be rho s a z over epsilon 0, the integral of 0 to b h minus z prime dz. dz is coming from here over h minus z prime plus a2 3 over 2. Similar integral. What is important? This part is important. This part is important. How you think as you extend that. It's a different way of integral. Okay?